Since we have used the quadratic formula to help us find two rational roots or one rational root, let's move forward using the quadratic formula to find irrational roots. Now, these are real roots. We are going to see the graph cross the x-axis, but they're not integers in the respect of being whole numbers or counting numbers or anything like that. But rather, and they're not going to be terminating or repeating decimals. They're going to be, in fact, irrational roots. Now, so here we got the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. We know that a is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant. And we just plug and chug our way through this. So let's see, negative b, well, that would be negative 5 plus or minus the square root of 5 squared minus 4, negative 4 times a, which is 3, times c, which is 1, square root of all that, over 2 times a, which is 3. All right, well, negative 5 plus or minus the square root. 5 squared is 25. And negative 4 times 3 is negative 12. And times 1 is still negative 12. So we've got 25 minus 12, square root of that, over 2 times 3 is 6. And we come up with negative 5 plus or minus square root of 13 over 6. And there's not any other simplification that we can do with this. And most of the time you're going to be asked to express this in the form of a radicand, since we don't have a perfect square here. And this would be an acceptable answer. We'll actually calculate it out here in a few minutes, because in a little bit I'm going to use the calculator and show you how you can approximate the zeros for irrational roots using that. But before we do, we're going to solve one more equation using the quadratic formula, a method that will always work to help us factor a quadratic equation. All right, so again, here is our quadratic formula. Our quadratic equation is x squared minus 8x plus 9, and let's go about just plugging and chugging here. So we got negative b, but this is negative 8, which means that's going to become positive, correct? Plus or minus the square root of negative 8 squared minus 4 times a, which is 1, times c, which is 9, and all of that's going to be over 2 times 1. So then we've got 8 plus or minus square root of negative 8 squared is 64. Negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36. Square root of that over 2. Let's see, and then we've got 8 plus or minus, let's see what we got here, 64 minus 36, 8, square root of 28, I believe. Yeah, 28 over 2. Now, I can do some simplification on that. So then I've got 8 plus or minus, let's see, 28 does have a perfect square contained in that, one of the multiples of that. So I could say it's the square root of 4 times the square root of 7 over 2. And then we got 8 plus or minus square root of 4 is 2 times the square root of 7 over 2. And then I can further simplify this. 2 will go into 8 4 times. 2 will go into 2 1 time. And so my final answer here then is 4 plus or minus the square root of 7. Shazam. All right, now I'm going to go and actually graph that first equation there. I'm not going to do both for the essence of time, but show you how you can use your calculator to approximate the zeros. All right, so you can see here in the calculator, I had already entered the quadratic equation of the first example we looked at as we're finding irrational roots, 3x squared plus 5x plus 1. And when we graph it, here's what we see. And I can see that I've got a root somewhere between 0 and -1, and then also between -1 and 2. And if I want to get an approximation, this will not be in a form of a radical, but it's going to give us an approximation. I can hit second calc, and then I can choose option 0. And you can see that I got a little cursor in there and it says left bound. I'm going to move it just above the x-axis, and I'm going to hit enter. And then it asks me about right bound, so I'm going to move it just below the x-axis and hit enter. Then it asks me if I want to guess, and I'm going to say yeah, why not? And I can see that x, where y is 0 here, x is equal to -1.434259, and that's going to go on out forever. And I guess I might as well do the other 0 too. So I just move the cursor along. Well, no, I'm going to hit 0 again. Let's go trace 0. This time we're going to move it just under the x-axis because that's left bound. I'm going to say enter. And then we're going to move it above the x-axis and enter. And again, it asks to guess. And when y is 0, x is -0.232. Now, if you recall, when we went into there, we had an hold on. Quit calling up here. All right, we had an answer that was, well, there it is. I've already entered it. I had -5 plus the square root of 13 divided by 6 was -0.232. And -5 minus the square root of 13 divided by 6 is -1.434. Shazam, there we go. We got it. But that's just an illustration to show how you can approximate a 0 on your calculator.